First of all, some disclaimers. This is not a calculus video. I know it says disk method, and we are going to talk about the disk method, but this is not a video about calculus. We're not going to talk about how to use the disk method. We're going to be talking about how to visualize the disk method. We're going to take advantage of that 3D printer you have at your school to help kids and possibly yourself visualize the disk method, washer method, and shell method. This is going to be video 1 talking about disk method specifically. Without further ado, here we go. Okay, so normally in calculus class, you get up there and you talk about, we're going to revolve this, taking into account these parameters. We're going to revolve y equals 1/4 x squared, although you probably would start with x equals 2 times the square root of x and then make them solve it for that. We're not really caring about that for this video, but we're going to revolve this about the y-axis. So we're going to only look at this from x equals 0 to y equals 3. So a good math teacher, of course, which all of you are good math teachers, is going to get up there and tell them, okay, you've got to sketch out this deal, and so you're going to come up here and you're going to sketch your axes, and you're going to label them, or, if you're lazy, you're not going to label them, but you want the kids to label them, of course. It's important, right? Or something. Okay. So then you'd have them graph it, and, well, I say graph. What I really mean is sketch. You're going to have them draw something kind of like this. This would be a parabola, but we're only looking at it from x equals 0. And if we graph the whole thing, it would also have all this mess. And then you're going to tell them, okay, we're only going to look at it from here, and we're going to look at it right here at y equals 3. This is 3. And you're going to take this and you're going to spin it around the y-axis. Well, this is pretty easy to visualize. This one's not bad. You can take this and kind of picture this spinning around. It's going to kind of make a sort of a cone shape. It's technically called a paraboloid. But, some of your students are not super great at visualizing this. This is an easy one. This one's a lot easier than some. In case you're having trouble seeing the region. If you're a calculus teacher, you're not, because you're used to teaching these things. But you're taking this little region, you're going to spin it around. Okay, so but the point is this can be hard for some students to visualize. Well, you have a 3D printer, or someone at your school does. And so I'm going to show you how to take advantage of that and actually spin this around in CAD, so we can actually get some CAD models, so you can do that. And then you can take it one step further and use a 3D printer and actually print out the physical objects, and you can hold up and let the students see. Way cool. Here we go. Let's dive in and take a look. You're awesome. Okay. This is going to be the computer portion of this instruction. So in order to create your revolution about a solid, we need a new part. This is Autodesk Inventor Professional 2016 edition. First of all, you want to make sure you're in the proper project. I don't actually have a project set up, so it's perfect. Real quickly, I'm going to create a new project, new single user project. I'm going to call this one 3D printing. Okay. And that's it. It's going to ask you and tell you that it doesn't exist yet. Should it be created? Heck yes, it should. Okay, good. As long as the 3D printing project is checked, we're good, and we can say done. All right. This also tells you in this new 2016 edition, it gives you this view so you can see already what project you're in, which is really nice. That didn't used to be in there. Okay, so we're going to click on the new button. We're going to go and we're going to use the English because we're going to measure in inches. You could just as easily do this in metric, which actually might have advantages size-wise. You can make smaller parts and have all the
dimensions be essentially the same, because like the example we looked at on the board, it's unitless, and so really you could do it either way, but I'm going to go ahead and keep it in inches just because I am. So you're going to go with a standard inches part, and we're going to say create. Once that loads up, see here in the main window, there's nothing, which is okay because we're about to make something from nothing. Let there be part. Okay, so we're going to start with a 2D sketch. Almost always in Inventor, you're starting with a 2D sketch. So we're going to click here. Now, you get all 3 planes. We are working in 3 dimensions. Just for standardness, if that's a word, we're going to go with the XY plane. So it gives you a little tip about which one you're using. So we're going to click on that plane, pop it up, and we're going to make us a sketch. The first thing we're going to do is we're going to actually make our parabola. Underneath the line tool, there's a little drop down, and we can go down, we can get equation curve. Awesome, because that's what we want. Now, when you first open equation curve, it's going to come up with a parametric option, which is cool. You do have several options here. You can do parametric options. You can use Cartesian or polar coordinates, which is super, super cool. But for just the basic example we're doing, we're going to use an explicit equation. You see it switches to a y of x prompt here, and so you can set it up. Basically, you already have your y in here, so you don't have to put y equals. I believe you can. You can test that on your own time. But, so we were going to put the equation 1/4 x squared. Now, there's a few things that you're going to have to know. There's a few kind of weird things. You may ask kind of, what the heck, Autodesk, but it's just the way you have to do it. So the first bit is pretty simple. You can put it in parentheses and do 1/4. Okay. You could, of course, do 25 hundredths in decimal, and that'd be just as simple. Now, you can't just type X. We have to actually put times X. It's like doing regular coding. It doesn't know what parentheses right next to a variable look like. Okay, so we're going to put times, which is the asterisk. In case you don't know where that is, if you hold down Shift and push 8, that's where the asterisk key is. All right, so then we're going to put X. Now, to do squared, we use the caret symbol, which is Shift 6. And then we're going to put squared. Now, this, I ran into a lot of trouble here because of this little error symbol. It took me about an hour, maybe even a little longer, to figure out how to fix this. If you hover over and click this error, it tells you equation y of x contains unit errors. Expected units are length. What the heck does that mean? Okay, well, it means you have to tell it what units to use. Now, there's a funny way of doing this. There may be an easier way of doing this. If there is, let me know in the comments below. Okay, I would love to know a simpler way of doing this. But the way I was able to come up with and find from the internet is if you put this X inside of parentheses, and then inside of here you divide by 1 inch. Bam. And then it works. Okay. I know that's a really, really awkward way of doing units, of sticking the units in there. Of course, if you do unit conversions, you may be kind of sort of used to a notation like that. Sort of. Not really. But anyway, that's how to get rid of that error. So this is 1/4 x squared is what we've typed in here. Now, the x minimum, x maximum are exactly what they sound like. Now for ours, we know we're ultimately going to only want to x equals 0. So the x min of 0 is perfect. So we'll leave that as is. It'll give us a nice little endpoint to work with later. Now the x max, unless you have done the bit of math to figure out where this parabola crosses the y equals 3 line, which is pretty easy math to do. So in class, if you were doing this and demonstrating this in class for whatever reason, you may want to do that math and actually put the right number. But since I haven't taken a couple of seconds to do that, and I'm a bit lazy right at the moment, I'm just going to enter a number that's going to be definitely big enough, because you'll see we're going to kind of cut through it in a minute anyway. So I'm going to put the X max at 10 and then hit our check mark. Now, if we hit the front key, it's going to zoom out, which of course is going to be too much. You'll find it's way too much coming down here. Now, we need our other lines, okay? So we need to get the regular line tool, which is up in here, and we're going to create 2 different lines. We're going to start at this endpoint. You'll see that it turns green. Okay, so after you do that, you're going to drag it up here and make sure that it says 90 degrees. Okay. If it doesn't say 90 degrees, then you're going to end up getting some weird things. So you can get lines all around the full circle. So you go up and you'll also see the vertical symbol show up there, 90 degrees. And if it says 90 degrees, vertical symbol, you can type 3 and then push enter, and then it'll dimension it so you don't have to go back and do it later. It's in Inventor, it's not that big a deal to go back and do it later. But you'll find if you do that, these equation lines aren't actually fixed, which I think is a design flaw, but what do I know? So you're going to go out a straight 90 degrees from there and come and make contact with your parabola. Then it's perfect. Okay, so there is your parabola. There is your sector that we're going to revolve around the y-axis. So we're going to finish that sketch. We can hit the home key. Now it's going to zoom out the full extent. If you were lazy and did it that way, you could have found this exact number and used it or something even closer. I was just lazy and decided to do it that way. Okay, so you can do a revolution around the x-axis. So in the revolve tab, probably if this is the first time you click the revolve tool, it's going to show up like this. If you don't see all that other junk, you just hit the arrow and bam, it shows up. So to select the profile, you're going to select your little wedge shape that you want. And for the axis, you're going to select this axis. This is actually the y-axis. If you're not sure about that, you can actually open up the origin. Now you should be sure because we just created it, but see, it's the correct axis. If you hover over the y-axis, it shows up in white there. Okay, so for the axis, you're going to select this line. If it's full, then there it is. There is your little paraboloid shape. Isn't it beautiful? Let me hit home so I can get a nice zoom. And see, there it is. Beautiful shape. Now, this is fairly useful. You could print this as is. In fact, I would recommend going ahead and printing a solid one like this so you can see the full revolution. But where this becomes particularly powerful in visualizing these revolutions is if we can actually see that cutout too. So to do that, what we can do is we can just select your revolution, double click it to edit it, and then instead of a full, you can go to a certain angle. Default's going to pop up 90 degrees, which actually is pretty cool by itself, but to me that's not even quite as good as if you go to a full 270 degrees. Okay, so then, now how cool would it be to print this out? And then you can Sharpie in right here, and then you can let the students see, and then they can see the original shape. I guess it would actually be this one. But they can see the original shape, and then they can see what the revolution would look like. And then if you printed the fully rotated one, then you could get kind of all the pieces of the puzzle. Very, very powerful visualization. I think it'd be super helpful for students that struggle visualizing these things. Stay tuned for parts 2 and 3 for the washer and the shell method. And in just a minute, I will show you the final 3D printed part. Thanks. Okay, guys. So I hope you enjoyed that tutorial. Here's the finished version. This is the full revolution. You can see it's all completely a full circle. Awesome blossom. Ready to go. Now, then I also created the 3/4 cutout version. The 270 degree rotation. Little Pac-Man. Just needs some little dots right here. Yeah. Okay. Anyway, I also took a moment to Sharpie in the original sector that was revolved around the y-axis, and so you can really see clearly what it looks like. So that's pretty cool. If I was going to use this in class, I would actually take the time to sand this model. You probably can't even tell in the video real well, but it's I printed this on pretty low quality, and so it's got a little bit of imperfections in it. And I probably would actually use paint and paint the whole thing a solid color, white color, and then use a actual black paint. So this would look really, really sharp then. But for just quick and dirty, just to get ready for the lesson tomorrow, this was a less than a 2-hour print to print both of these. It even printed them at the same time instead of separately, which I'll link in. Well, not link in, but I'll include in a little bit of the video of these printing. But anyway, hope you enjoyed it. Have a awesome day, and you are still awesome.